Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. We're going to continue talking about the linked list. Some of the code that we're going to type is a little bit redundant and similar to what we've typed before, but again, this is just to help solidify your understanding of linked lists. So I'm creating a C++ program, empty project. I'm going to call it CS232 linked list part 2. Click OK. And because I selected the empty project, I have to go to the Solution Explorer to create a source.cpp file. So when this is finished, it should be pretty soon. There we go. So I'll go to the Solution Explorer, Source Files, right-click, add a new item. And I want a C++ file. It's going to call it source.cpp. That's fine. So I'm going to click Add, and then let me go ahead and zoom in just a little bit so you can see my code. And we're going to start off with the boilerplate stuff, such as include IOStream, using namespace, std, int main, open and close curly braces. We're going to say system pause, so we can see what the program looks like at the end, return 0. And yeah, that's it. Go over here above the main function, and of course below, using namespace. And what we learned last time when it comes to linked lists is that a linked list contains an item and then it points to another one of the nodes. A node is something that contains an item and a pointer. Well, in order to accommodate this, we learned that we can use the structure, or the struct, because a struct can contain many data types within it. So let's go ahead and type in struct, and I'm going to call this ages node, and open and close curly braces. Notice that Visual Studio puts the closing brace with the semicolon. That's nice. I'm going to create an age variable. And I'm also going to create an ages node, and we'll put link over here. So what is this? This is going to contain an integer, which we're identifying as age, and we are going to create a pointer, which we are calling link. And what is this going to point to? Well, it's going to point to another one of these guys, an ages node. So for however many nodes that I have, these nodes point to each other and they contain data. So the struct ends up being a beautiful way. Because what is a struct anyway? A struct is a collection of nouns. What is a class? A class is a collection of nouns and the verbs that act on those nouns. For example, if I said this was class, if I had age, then I'd have get age, set age. Get age and set age are the verbs that act on the noun age. A struct is a collection of nouns. All right, so now that we have this, let's go ahead and create our declarations in the main function. I'm going to create a variable called num of ages, which basically is asking the user how many values are we going to have. So we'll say the number of age values requested by the user. Next, I'm going to create an ages node, and we're going to call that the head node. And the way that I'll establish this is I'll say new ages node. So this points to the head node that we've just created. Now I can assign values to the head node such as follows. I can say head hyphen and then the greater than symbol. So this is the member access operator, these two guys together. So what we're saying is I would like to access the members of what I am. What am I? I'm an ages node. And what does an ages node have? It has the integer age member, and it also has this link member. And so that's what you see over here. You have access to those. So over here, I can say, in terms of the age member, I would like to set that to an initial value. Well, let's just set it to 49, or whatever value you want. And then in terms of the head node, and once again, I'm going to use that member access operator, which is the hyphen and the greater than symbol. Notice that I have access to the link as well. So I'll double click on that. Now, what is this? This is a pointer. So you know what a pointer is. A pointer points to a memory location. If it's not pointing to a memory location, then you want to establish that as pointing to the null pointer. So it's either pointing to something or it's pointing to the null pointer. All right, at this point, I'm going to create an initial linked list of values based on the user input. Now, the strategy, and in fact, let me just go ahead and open up graphic, and I think I had a lecture that helps to graphically see how this works out here. So it was a recent document here. Let's see here, linked lists. Yeah, I think that's it. Ah, yes. This is a great way to visualize what's happening. So I have this head node, and I want to assign like the next ages node. And the next ages node is going to be this one. So this is going to point to the next ages node. I'm going to give that a value, and then I'm going to give it a reference of null. And then when I add another value, then this is going to be the next ages node, and so forth and so on. It's how we propagate it, how we grow this linked list. All right, so we're going to say ages node. And we're going to create a next ages node. So I'm using the new keyword, ages node. Then we'll say next ages node. There it is. We are going to assign that for whatever the head is. We're going to assign that to next ages node. So we'll say this. We'll say next ages node is the first node. So let me go back over here to my graphic. Let's see, do I have next ages node? I do. So let me see if I can copy this. Okay, so what are we going to call this node? We're going to call it head. We've already done that. By the way, we are also calling it next ages node. See, the head, whatever the head is, that's also going to be next ages node. So this really has two different ways of being referred to. Similar to the example that I gave to you in the previous lecture, when I go home, my wife calls me one thing, my son calls me another. But they're both referring to the same item. So that's what's happening at this line of code. All right, so now let's go ahead and create a cout statement. How many ages are you going to enter? And let's get that value and put that into num of ages. So now I have from the user the number of items that they're going to be entering, and then specifically they are integer items. So within a for statement, I'll just go ahead and create a counter called I. I think the more formal term is enumerator, right? So this is going to be enumerating. I is treated as a counter. I could have put CNT, abbreviation for counter. I could have typed out the word counter. You'll see a lot of computer scientists. Now, this is the only time that I'll be so brief and use a single letter, because you know how I like being verbose. I like descriptive declarations. Here, this is a local variable I that only exists for this for statement. That's okay. As long as this counter is less than num of ages, and then I plus plus. So in the for statement, keep on repeating this over and over and over again, one by one, as long as I, our counter, is less than the number of ages. So once we've got that, let's go ahead and get our information from the user. So first of all, I'll say next ages node, and I want to refer to one of its members, so I have to use the member access operator, as you see here. And what I'm going to do is I'm going to refer to the link. What I'll do is I'll create a new ages node. So this creates a node at the end of the list. All right, let's go back over here. Let me get rid of this 22. And I'll get rid of this node right here. Null pointer. We don't have the null pointer yet. What's happening over here is we're saying, okay, in terms of next ages node, which is this guy right here. This is next ages node. It's also called the head node. All right, the link aspect, or the link member of next ages node, I'm going to have you point to a new node of type ages node. Okay, so you are pointing to a new node of type ages node. So this is what we've got here. I don't have any data. I don't have what this thing is pointing to. I just want you to point to a new thing of type ages node. Okay? So now that we've got that, we're going to say next ages node is going to be assigned next ages node, and I want to access its member, specifically the link member. And what does this thing do? It points to that node. So I'm going to show you graphically what's happening. Okay. What am I going to put into next ages node? Well, right now, next ages node is this node right here. I'm going to say, hey, the thing that you're pointing to, well, what am I pointing to? I'm pointing to this node right here. That thing that you're pointing to, that's what I want you to become. What am I pointing to? I'm pointing to this. Oh, so that's what you want me to become. So now this thing is called ages node. Does that make sense? Okay. So what are you pointing to? This. Okay, that thing you're pointing to, I'm going to assign you next ages node. Do you remember a next ages node used to be this guy? Now it's this thing over here. Next, we'll type next ages node, and I'm going to use the member access operator. I specifically want to refer to the link. I'm going to have you point to the null pointer. So remember, pointers have to point to something. They're either pointing to a certain memory address location, or you have to assign it null pointer. So I'm saying, okay, next ages node, specifically the link portion, the link member. Oh, that's this guy right here, the link member. Okay, so for the link member, I want you to point to null pointer. Oh, okay. So what that means is I am pointing, well, actually, let me, oh, good, it's an arrow. I can just click this guy. I want you pointing to the null pointer. That particular number right there. Good. Now, let's get the age from the user. So I'll just simply say cout. Enter age. Now, I want to say something like this. Enter age 1. Enter age 2. Enter age 3. For however many ages the user wants to enter. So I'll say enter age, and then I have a counter called I, as you can see up here, that's counting from 0. So I don't want to say enter age 0. I want to say enter age 1. So what we'll do is we'll just add 1 to this. So that way, that's 0 plus the 1. So it's going to say enter age 1. And then I'm also going to send out a colon with a space to give the user some a one space to enter the data, and that's going to be via the cin statement. Next, ages node. Okay. Now let me stop right here. I want to put the value that is entered by the user into the age member of my node. So let's use the member access operator. And specifically what I'm saying is, hey, the thing that you're about to type, put it into the age member of this node. Semicolon. So what's going to happen is the user types in a number. We are going to put it into the age member of the next ages node. Well, here's the next ages node, this guy right here. And let's say that the user types in 22. So the number 22 is placed into the ages node, into the age rather, member of the next ages node. That's it. So this for statement really is going to obtain the user data and place it to the newly formed nodes. That's what this section of code does. After the user enters the data and places it into the nodes, let's display the data so that we can see what was entered by the user. So we call that traversing. So we're going to traverse the linked list and display its contents. So first, let me let the user know what I'm doing. I'm going to say endl, and I'll send out another endl statement so we have a blank line in between. And then I'll say traversing the linked list. Then I'll put endl. Okay, so if I want to traverse the linked list, I had better go back to the head node, to that first node, display its contents. What are you pointing to? This guy over here? Okay, now I want to refer to this node, display its contents. What are you referring to? This node over here. Okay, let me display its contents, and so forth and so on. So in order for me to do that, I'm going to have to say next ages node. Oops. Okay, let me get this guy out of the way temporarily. Do this. That way I can grab this guy. There we go. What I need to do is I need to say, okay, first of all, head, what are you pointing to? Oh, I'm pointing to this node. I am this node. Okay, whatever you are, that's what I want to become. I want to go back to the beginning of the list. So we'll do this. Next ages node is going to be assigned whatever the head node is pointing to. So the member access, and I'll say link. And you know what the head node points to? The first node. That's what we call it, the head node. Well, once I've got that, now I can use a while statement to propagate through each of the different nodes in the linked list. So I can say while the next ages node is not equal to null pointer. What the heck does that mean? Well, right now, the first node has two nomenclatures. Calling it the head node, we're also calling it the next ages node. Then I'm going to be referring to this guy. Then I'm going to be referring to the next node, whatever that happens to be, and the next node, and the next node. Okay, so here, here, here. Finally, I'm going to get to a node that points to the null pointer. Well, that's the last node, obviously. So that's what this means right here. Okay, so while the next, because what we're doing is we're going to say, okay, first of all, you are next ages node. Now you are next ages node. Now the null pointer is next ages node. So once we get into this situation, stop looping. There's nothing more to gain access to. So we're going to be moving this step by step. So that's what I mean. As long as the next ages node is not the null pointer, which of course is the last thing pointed to. So while that is the case, then we'll just simply say cout next ages node. Specifically, let's access one of the members. So I'm going to use the member access operator. And I specifically want you to display the age for the particular node that you are referring to. And then end else statement. Since we are at the head node, it's going to display the 49. So 49 gets displayed to the output. I need to now go to the next node. So what I'm going to do is I'm going to say, hey, what are you pointing to? I'm pointing to this node. Oh, the thing that you're pointing to, I now want to assume that name. So now you are next ages node. You can think of this as, in the Olympics, they have that, they always save the best for last, that 440, the 440 race where each person runs a quarter of the track. These men are running, I don't know, 20, 25 miles per hour. It's incredible. And they have a baton. So I am the baton holder. I run, 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 run. I hand off the baton to the next runner. Now I'm the baton runner. And they hand off the baton. So you are the baton runner. Now you are the baton runner. Now you are, and so forth and so on. The baton is literally handed off. You can think of it that way. That's exactly what's happening here. So I need to hand the baton off to the next runner.
Is there a reason why you specifically set up the number?
So that you have some initial starting point.
So what if we want to put an initial
Yep. So I will call this the head node. I will call this the next ages node, and then ask the user to give me a value and put it right into there. So that's exactly what you were describing. You have to create some sort of a head node. We'll call it next ages node temporarily, place a value into that, and now go to the next one. So do I have to give this an initial value? No. No, I don't. I do it so that you understand that this thing has an ages or an integer value and a pointer value. But I put 49 over here and the user types in 33. That 49 gets overwritten by a 33. Yeah. Okay. So now we'll type next ages node. I now want to become the thing that you are pointing to. So I'll access the member link. So what this does is it says, all right, what are you pointing to? I'm pointing to this node. I'm now going to call you next ages node. That's what this is. What are you pointing to? Whatever you're pointing to, that's what I want to become. So this is the code that we looked at last time. Now let's get into some new stuff. For example, let's say that I want to double the contents of the linked list and display the results. Let me save my work. I'm going to do a temporary run just to show you what this looks like. Now, before I do that, just did a no-no. In C++, the one thing you have to remember is memory management. And that's something that I'm so lazy now, I don't have to worry about that in Swift or in C#. I don't have to worry about memory management, or if you're a Java programmer, because you have the garbage collector or the automatic resource counter in Swift. In C++, you do have to worry about memory management. So you are literally creating memory reservations, you are obtaining that memory, you're using it, and then when your program closes, it's still being used because you didn't free that up. That's what it means when I say memory management. The memory that you are consuming, you now have to give that up. You have to let someone know. I love it when my in-laws, they're very nice. They allow my wife and I to go on vacation with them, right? So we go to the pool. And the unspoken rule is if people place a towel on those chairs, the lounge chairs or the regular chairs, you can't take them. They're saved. So I go in there, nobody's in the pool, and all the chairs have towels on them. Because those people intend on coming at, maybe 9 or 10 after they've slept in a little bit, and there's the chair because the previous night they put a towel over there to reserve that chair. And I get mad because there's no chair available. And I don't want some big guy beating me up. Hey, that's my chair. So I got to get there early to reserve a chair. If you reserve a chair, that chair it's even if you're not sitting in it, it's available for you to use when you take your towel off. Then somebody else can use that. It's exactly what's happening here. I need to take that memory and say, hey, Windows, free store, here you go. That memory is no longer being occupied. So I'm going to type a comment down here that says delete the head node from the free store memory. This will always be at the bottom of the code, so it will always be the last thing to do. And the way that you do that is you're going to say delete head, and then you are going to set the head to the null pointer. These are the two steps that you take to make sure that you have released that memory to the free store. I also have to delete the next ages node, because I also created that. And so the next ages node, we're going to assign that to the null pointer. As I create more and more nodes, I'm going to have to go over here to this section and delete them. So this is something that you have to do as a C++ programmer. All right, before I continue, run the program. You don't have to run it. I'm just going to see what happens here. Make sure everything's working fine. Okay, how many ages are you going to enter? I'll enter 3 ages. 49, enter 22, and 13. Enter. Traversing the linked list. Okay, so 49, 22, 13. Yep, looks like it's working okay. So I am obtaining the data. Let me stop the program right here. So I enter 3 ages, 49, 22, 10, say for example. Stop the program right here. Okay, so this right here tells me the head node has a number 49, and it is pointing to another node. Now that other node, which you know what pointers do, they point to memory address locations. That other node is going to contain the number 49, and it is pointing to something. Okay. Now that other node is containing the number 22, and it is pointing to the null pointer. So do you see how we're propagating? And notice that I am pointing to an address location. So this thing contains an address, and then this thing contains an address, and then this thing contains the null pointer. All right, let me stop. Okay, so now let's just kind of experiment and have fun with our linked list, making sure that we can do stuff like modifying the contents, adding a node to the front of the list, not to the end of the list. How about maybe determining how many items that we have in a particular linked list? And so we're going to get the frequency. And what if I wanted to, probably one of the most difficult things, is reverse the linked list. So this is pointing to this is pointing to this, and now I want to reverse that. Okay, so how do I do all that stuff? And that's what we're going to do. Okay, so first let's deal with doubling the contents of the list. So let me just go ahead and send out a message letting everyone know what I'm doing here. So go to the beginning of the next line, and then I'll say we're doubling the contents of the linked list. And go to the beginning of the next line. I got to go to the beginning, so I got to have this thing go back to the beginning. So whatever head you are pointing to, that's what I want to become. So next ages node Whatever the head node is pointing to, I'm going to refer to the member called link. Oops. Link, this guy here. Okay. Now I need to propagate through the linked list, and for every integer, I need to double it. That is to multiply times 2. So I can use a while statement. While next age's node is not equal to the null pointer, then continue propagating through the list. So now we'll take next age's node. I'm going to refer to the age member. And what do I want you to become? Well, whatever you are, I want you to be doubled. So whatever you are, age, next ages. There it is, next ages node. Whatever you are, age, I'm going to multiply you times 2. I'm going to basically double your contents. So this is like the old value of age times 2. Now this is the new value of age. Let me output the contents. So we'll just simply say cout, next ages node, specifically the age. And we'll go to the beginning of the next line. So I can see what the value is. Okay, you are currently next age's node. Now I need to move you over. So the thing that you're pointing to, I now want to become this, so that I can double your contents. So next age's node. Whatever the current value of the next age's node is, I'm sorry, thought we've already done that. Whatever you are pointing to, sorry about that. So next age's node. Specifically, whatever the thing is that you're pointing to, I now want to become that node. So you're pointing to this. Okay, I want to become that. The thing that you're pointing to. Okay, so that is how we modify data. Now, in this case, I'm just doubling, but maybe perhaps you want to create a running sum or a running product or the multiplication of the division of, or whatever it is, the mathematical operation. This is how you would do it. You would just simply propagate through the list, modify it in some mathematical form, and then in this case, we're just outputting the data. All right. Next, let's do this. Let's create a node. So let me duplicate this and put it in the front of the list. Well, if I do that, guess what I'm going to have to do? I'm going to have to say, okay, you are now head. And by the way, you now point to this, right? If I want to move a node to the front of the list, this is graphically what it would look like. Take a node, put it over here, make sure that it's pointing to the new thing. How do we do that? All right, so adding a node to the front of the list. That's what we're going to concentrate on. So let me go ahead and create a new ages node. And we're going to call that new ages node. What are you going to be of type? I'm going to be of type ages node. Let me show you analogously what's happening here. So I don't have this yet. And the head node so far is this guy over here. Now, I put this in the front of the list because that's eventually what I want to do. But really, all I've done is I've just created this. I'm going to put it over here. This is my new ages node. What did I call it? New ages node. Okay, so this is new ages node. Boy, it's pretty tough writing with the mouse. All right, this is the new ages node. Doesn't have any data in it, doesn't point to anything. It is a node. That's all we know so far. Okay. Now, new ages node, the thing that we just created, I specifically want to refer to your member, specifically the link member. The thing that you're pointing to, what I want you to do is I want you to point to whatever the head is pointing to. What are you pointing to? What is the head node pointing to? Well, this guy right here. The thing that you're pointing to, I want you to put that into the link member of new ages node. So in other words, what we're doing is this. I want you to point to whatever the head is. Okay? So you are going to point to the head. That's what we've just done right here. All right? Comments or questions? I see confused faces here, so I want to make sure that you understand what's going on here. Let me backtrack. Take this away. At this point, at this point right here, you've created a new ages node, and you're calling it, you're creating an ages node, and you're going to call it new ages node. So here's a node, you're going to call it new ages node. It's just out there in space. I would love to do this. I would love to move this over here and saying, hey, head, what are you pointing to? Oh, this guy right here. Well, I want to point to that thing that you're pointing to. So I want to do this. I want to point to whatever you're pointing to. Well, that would mean that this link member is going to point to the head, and that's what this part does. What are you pointing to? I'm pointing to this guy. Okay, great. The thing that you're pointing to, I, in my link member, want to point to that as well. And so this is what's happening, basically. Well, now, we'll use a cout statement. Go to the beginning of the next line, and del, and we'll say adding a new node to the front of the list. And del. That's what we've just done. Then I'll say, what is the value to be added to the front of the list? And I'll put a question mark, close quote, and end it with a semicolon. Okay. So I've got this node here. It is pointing to this, but there's no value in it. We want to give it a value. So that's what we're asking the user to enter, and we'll say C, and let's get that value. We're going to put it into this thing that we've just created called new ages node, specifically to what member? Specifically to the age member. The value that is about to be entered by the user is going to be placed into the new ages node age member. And so they enter the number 7. So they enter the number 7, and we put the number 7 over here. So let me do this here. They put the number 7 over here, so now that front node has a value. Hey, that's the front node. So I better do this. Watch. Shouldn't I do this? That's my new head node. So let's do that. The head node is now going to be whatever new ages node is. The new node is now the first node in the list. Save my work. Well, let's traverse the list to make sure that we are actually looking at this new item. Okay. So traverse the list. So I'll just simply say cout at the beginning of the next line, and del, and then I'll say traversing the list again. Traversing the linked list again. So we can see what its contents are. Well, that's going to take place within a while statement. Hey, as long as this new ages node is not the null pointer, or we haven't reached the end, then we're going to keep on propagating through the list. So let me display the contents. So the new ages node. Specifically, I'm interested in the age member. So the age member. And then I go to the beginning of the next line, and del. So I've just displayed the 7. Now I need to do this. New ages node, I need to move you over and now display your contents. And then I need to move you over and display your contents. And then move you over. Oh, you're the null pointer? Stop. So we're going to be moving step by step. A little there. Hey, can I group this? Oh, nice. Should have done on the beginning. Okay. Go back over here. New ages node is going to be new ages node, and specifically the member that I want to refer to is the link member. Hey, what are you pointing to? I'm pointing to this guy. Hey, the thing that you're pointing to, I want to now become that. That's what this statement does. So we traverse the list. Next, let's determine how many items are in the linked list. So determine how many items are in the linked list. Okay, this is called lazy instantiation. Typically, I put all my variables at the top of a program in the declaration section, but you don't have to. I like to do that because it seems to keep everything nice and neat. I have one place that I can go to find all that, all the declarations, but you don't have to. So in this case, I'm going to create an item count. We'll start that at 0. Next, the new ages node. See, because this thing propagated from here to here to here, and at the end it's over here when we traverse the list. So you know what I need to do? I'm going to move this guy over here. Whatever the head is pointing to, I need to move that back to the beginning of the list. So we'll say new ages node. It's going to be the head node. Oh, by the way, I just created this new ages node, so I better delete it as well. So delete new ages node, and also new ages node, set that to the null pointer. That way it frees up the memory, gives it back to the free store, which is a collection of the memory that you have access to. Okay, so now back over here, now that I am looking at this, okay, so counter is equal to 1. Am I able to move over to another node? Yes, counter is equal to 2. Counter is equal to 3. All right, that's it. We're at the null pointer. So it looks like I have 3 items in my list. That's exactly the strategy that we're going to go through. So I'll say while new ages node is not equal to the null pointer, item count plus equals 1. Now, the only reason why I'm doing that and not plus plus, guess what C++ is doing? They're deprecating this. You ever heard that word before? Deprecation? It's a computer science term. It means we're no longer doing it that way. You know, I said to my son, wow, look at that motorcycle. It's beautiful. He goes, no, Dad, you don't say that. I said, well, what do you say? He goes, that motorcycle's sick. Oh, okay. Why? That's the new way of talking now. So now I'm constantly misabusing that term. Oh, Joshua, look at that. You know, that program is sick. No, Dad, you're not using it right. Okay. So to deprecate means we don't do it that way anymore. We're doing it this new way. Plus plus is being deprecated. Plus equals 1 is how they're going to do it now. That's the new approach, is to just say, just change everything to the shorthand notation, which really means this. Item count is being assigned item count plus 1. You're incrementing by 1. Now, let's take the new ages node, and we are going to assign to it whatever the new ages node is pointing to. So I want to access the member called link. What are you pointing to? Oh, I'm pointing to this guy. Well, the thing that you're pointing to, I now want to become that. So now this is my new ages node. Well, I keep on doing this, adding 1 to the item count, and therefore I'm able to determine the number of items in the linked list. Now, shall I do it this way when I'm creating a linked list? No, I'm just showing you to demonstrate very carefully, very meticulously, step by step. You know what you should probably do? Create an item count right from the get-go so that as you add items, then you increment item count. I'm doing it this way to kind of really flesh out how this is going to work. When we're done, we'll just simply say cout endl statement, the linked list has, and then in this case, we have the number of items via a variable called item count. And then quote space item. And then we'll go to the next line and go. Save my work. Okay, so maybe you want to get the frequency of an item in the list. That is, how many times does an item occur in the list? So let's work on that. Get frequency of an item in the list. That is, how many times does an item occur in the list? So the first thing that I want is an entry of type integer. I'll set it to 0 initially. I want to know how many times that particular entry exists in my list, so I'll create frequency. And I'm also going to create a counter. I'll set that to 0 as well. Cout, let me go to the beginning of the next line, and I'm going to say get the frequency of this number. So I'm going to have the user enter that number, and we're going to put that into a variable called isEntry. So now we're going to have to propagate through the list and ask. Let's say that the user enters the number 7. So I go to the first node, are you 7? And then I go to the next node, are you 7? I go to the next node, are you 7? And if it is, then I increment the frequency. If it isn't, we just ignore it and go to the next node until we get all the way to the null pointer. All right, so what I'll do is, okay, this next ages node is pointing to this, and then eventually it's going to be, I got to go back to the beginning of the list. So whatever the head is, that's what you are going to be. So I can propagate through the list. So see, this is very important. If I don't know this, I'm lost. I have no idea where to begin from. So I've got to have that head node every single time you have a linked list. So that I can do this. New ages node is going to be whatever the head node is. Whatever you're pointing to. While the new ages node is not equal to the null pointer, and so logical and is this, while the counter is less than item count. Now, I personally don't like this. It could very well be that the precedence is that this is going to execute first and this is going to execute second. So you know what I end up doing, just for readability purposes? I do this. Because to me that looks like groupings. This and this. I don't need that space. Okay. So I like to do that. Is it necessary? Probably not. But for me, it seems very clear. I want to find out what the answer is here, true or false. I want to find out what the answer is over here, true or false. And then I will apply a logical AND to those two Boolean expressions. All right. Is new ages node, as long as new ages node is not equal to the null pointer. That's true. We're not equal to the null pointer. We're over here at the first node. And while counter, which I started off at 0, is less than item count. Well, I just obtained the item count. Let's say that I have 3, 4, 5, whatever that is. Yeah, 0 is less than 3, 4, 5, whatever that value is. So then I can go into the while statement. And here I'll have an if statement that says if the new ages node, specifically the age member, if that's equal to an entry, which is what the user said, I want to find the frequency of this number, whatever that happens to be. Well, if the thing that you contain, whatever the number is, in this case it's 7, is the same as the user's entry, well, then I need to increase the frequency. So over here, we'll just simply say frequency plus equals 1. If it's not the same, then we're not going to increase the frequency. Now we got to get ready for the next potential iteration. So we'll just simply say counter plus equals 1. Now, before we go back to the beginning of the while statement, I've got to do this. I've got to say, okay, so the thing that you are pointing to, I now want to become that. So I can take a look at its contents. So over here, new ages node is going to be the thing that you are pointing to. So the member is link. Whatever you are pointing to, I now want to become that. When we're all done with the while statement, oops, sorry, undo. When we're all done with the while statement, then we can just simply say an entry occurs, and then whatever the frequency is, times in the list. It could be that it's 1, so I'll put this, the open and close parentheses. It's either 1 time or 2 times, 3 times, so forth and so on, in the list. And del. So eventually, this thing goes from here to here, and eventually it's going to end up with the null pointer. Okay, now let's do probably the most difficult, which is not too difficult. We just have to follow it step by step. Let's reverse this list. So what I'm going to have to do is I'm going to have to say, okay, this guy is going to be my new head node. This is going to be the second item. This is going to be the item that points to the null pointer. So let's reverse this. We got to be careful. I don't know who is pointing to me. I only know who I am pointing to. So I can't say, oh, go to the guy before me. I don't know who you are. Over here, I can't say, okay, now you're going to point to the null pointer. Watch this. If I do this, this could be a catastrophe. If I do this, guess what has happened? Now you have what is referred to as dangling nodes. I have no way of erasing this. The only way to erase this is to shut down the computer and turn it back on to flush the memory. Because I have lost where this is. Where is this? I have no idea. I didn't assign any type of nomenclature to you. So this is a catastrophe. We don't want to do this. We have to be careful to make sure that we always maintain who's the next node, who's the next node. It would be as if we're playing that game that I was talking about where you hold your friend's hands next to you so that I can squeeze the number of pulses to the next hand and they squeeze one less. And then all of a sudden, like two people decide to no longer hold hands. Like these two, they're holding hands, but they let go of the hand. We have no way of transmitting beyond them. That's it. The link has been broken. We don't want to do that. So let me undo. That's a no-no. We've got to be careful of this. So how should we go about this? Well, we're going to show you step by step. Reverse the list. Let's let the user know what we're doing. Cout and del reversing the list and del. We are going to create three nodes: a parent ages node, a me node, and then a child node. So we'll say ages node, and we're going to create the parent ages node, which is going to be a new ages node. We're going to create the me node, which is going to be a new ages node. And we're going to create the child ages node, which is going to be an ages node. Now, if I do that, I better make sure that I delete these. Parent, me, child. So I'm going to go over here. And by the way, notice that I'm deleting the head first, then I'm deleting this, then I'm deleting this. So I'll just keep on deleting these in order. So we'll say delete the parent ages node. We'll assign parent ages node to null pointer. Delete the me node. And then me is going to be assigned to null pointer. And then finally the child ages node. The child ages node. Child ages node is going to be assigned the null pointer. I like to do that. That way I don't forget, oh, forgot to delete those nodes. Now they're dangling in memory. The only way to free them up is to turn off and on the computer. Let me do some typing, and then as Ricky Ricardo said, then I'll do some splaining. You guys don't know Ricky Ricardo. I used to love this movie called, or this TV show called I Love Lucy. And I Love Lucy's husband had a very heavy Cuban accent. So he says, you have some splaining to do, Lucy. So I'll explain after I type this. We'll say parent, ages node, is going to be assigned head. Me is going to be assigned parent, ages node, specifically the member link, whatever you are pointing to. And then child, ages node, is going to be, first of all, I need to access the me link member and assign that to child ages node. Next. Oh, okay, it's finished. Good. Okay, so let's see. This right here is done, so let me close this. Sorry about that. For those of you who are on my video lesson, I'm recording and doing this at the same time. Okay, good. We're still recording. Good. And then over here, we'll say parent, ages node, specifically the link member, and we'll have that point to the null pointer. So this is the tail node of the list. Save my work. Okay, so let's go through this, and let me create some graphical explanation of this. So parent ages node. Okay, so let's go over here, and I'll just simply type in text over here. So this is going to be the parent ages node. That's way too big in terms of the font. Can I make it a little bit smaller here? Where's the size? 14 points, good. Parent ages node. Let me duplicate this guy. So I create the me node. Duplicate this guy. And what did I call it? Child ages node. Child ages node. Okay, so I have these nomenclatures. What am I doing first? Assign parent ages node to the head node. Okay, so this is the head node. So this is also going to be referred to as the parent ages node. Over here, the parent ages node link is going to be assigned to me. So what is me going to be assigned? Whatever the parent ages node is pointing to. Well, what is the parent ages node pointing to? Oh, it's pointing to this guy. So that says whatever you're pointing to, we're going to call it me. So this is this over here. That's me. Let me just take this out of the equation for right now. What does the next line of code says? All right, hey, whatever you're pointing to me, all right, so me, what are you pointing to? I'm pointing to this guy. I'm going to make you the child ages node. Okay, so you are pointing to this. I'm going to make you the child ages node. So everything okay so far? Just assigning the various names here. Parent, me, child. What do I do next? The parent ages node, specifically what you are pointing to. Okay, so specifically the thing that I'm pointing to, I want you to be now null pointer inside of the link property. So on the link property over here, the parent ages node, I am now going to do this. You are now pointing to the null pointer. Now that's okay, because this guy has a reference. This guy also has a reference. So I can disconnect that now and say, okay, I'm pointing to the null pointer, because remember, this was the head, now it's going to be the end. Okay, so far so good. Now, within a while statement, as long as the child ages node is not equal to the null pointer. So let me type, and then I'll explain. In terms of the me node, I want to access specifically the link. I'm going to assign that to the parent ages node. Then the parent ages node, I'm going to assign that to me. For the me node, I'm going to assign that the child ages node. Finally, for the child ages node, I'm going to assign that to whatever it is that you are pointing to, specifically the link member. Okay, save my work. This is what I've typed so far. Let's now go back graphically and follow step by step what's happening. Okay, so let's see here. Specifically the member for me. Okay, so the member for the link member, that is, right? The link member for me. That's this guy over here. I want you to now be pointing to, or put into whatever this link member is, parent ages node. Okay, so this guy, I don't want you pointing over here. I want you pointing to the parent ages node. So I'm going to move some stuff around here. Down here. Be careful here with my graphics. This is gone. What am I putting into you? Point to the parent ages node. Point to the parent ages node. Does that make sense? Okay. Are you already starting to see how we have 1, 2, 3, and we're doing this, and then this, and then this? It's like this shuffling around business. That's step 1. Parent ages node, it's going to be the same thing as me. So, me, you are also now going to be called parent ages node. Over here, me, you're going to be whatever child ages node is. Okay, so child ages node, that's this guy over here. So me, this guy has 2 names. It's called me, it's also called child ages node. Okay. And then child ages node, whatever the thing is that you're pointing to, that's what I want to become. Well, what am I pointing to? It looks like I'm pointing to, I think this was still the null pointer, right? So I got to copy and paste that. Still, it's pointing to a null pointer. So the child ages node, whatever it is that you're pointing to, that's what I want to be. Okay, so the child ages node, that's also, I'll put it down here, the null pointer. Okay, so then I go back. As long as the child ages node is not the null pointer, then we continue to do this. So what's happening is it's just shuffling. 1, 2, 3. Okay, so now this is going to be pointing to this, and this guy is going to be pointing to this. So it's kind of like, I know you can't see this on the video lesson, but on the board I'll just write 1, 2, 3. So we'll say this guy is now going to be pointing to over here. So in essence, it's moving this one over here and taking the last item, now if I have the total of 3 items, and moving that over here. This is pointing to the null pointer, our last item. And so in essence, you reverse the list. That's what's physically taking place. I've got to wrap it up here. Running late. So the next thing to do is me, specifically the link member. I want you to refer now to the parent ages node. The head is going to be whatever me is. We're going to assign me into the head. Next ages node is going to be whatever the head is. So this is the next ages node, who's now the head node. And then we're done. So I, one more time, want to traverse the list. Let me see if I can take some code here that I've written before in terms of traversing the list and just do a copy and paste. So traversing the list. Is there one with a next ages node? Reverse the list. No, it isn't. Okay, I'll just take this and modify it. Copy that. Make it a little bit faster for me. So we're going to traverse the list. I'm going to go to the beginning of the next. And so we're going to traversing the reversed linked list. Take the way word again away. While next ages node, not new, while next ages node is not equal to the null pointer. So we'll say cout next ages node, specifically the age content, go to the beginning of the next line. And then we're going to propagate by setting the next ages node to whatever the next ages node is pointing to. So we keep on going through the list, and it's going to traverse the content. So let me run it, and let's see what happens. Okay, how many ages are you going to enter? 3. Let me just put 10, 20, and 30. Now, traversing the linked list, 10, 20, and 30. Doubling the contents of the linked list, 20, 40, 60. Yep. Adding a new node to the front of the list. What is the value to be added? I'll just put the number 1. Enter. Traversing the list again, 1, 20, 40, 60. That works. Okay. The linked list has 4 items. Get the frequency of this number. How many times does the number 20 exist? Oops. What did I do wrong? Program crashed. Of course, it crashed in the middle of a video lesson here. Let me see. Let me see. It says over here, debug information required. Oh, what did I do wrong? Is it stopped somewhere over here? Throw an exception. Let me see here. Next ages node. Well, I have it here in my notes assigned to. Did I do something? Where did I do that?
Right there.
Michael?
The
Oh, right here?
Yeah.
Why did I do that in my notes? The next ages node is now the head node. Because I want to bring it back to the beginning. That way I can traverse through the list. So I want to do this. I want to take the next ages. Well, I mean, I messed up my. But the next ages node, I want to be able to do this. Go back to the beginning of that and then propagate through the list, which has been reversed. Okay, I don't know what I did wrong. I'm going to have to go home and I'll figure this out. I'll add this to the end of the video lesson that I'm going to end right now and figure out what's going on. But I think you understand the idea is that we are going to reverse whatever the content is in a linked list. How are you going to do that? The only way that you can do that is by creating a parent ages node, a me node, and a child ages node to help you reorder the list. Okay. All right, so I'm not going to say this is Professor Robert Solis. I hope this video lesson was helpful because I'm not at the end yet. When I get to the end, I'll tag on that additional video lesson to the end and explain how this works and how I fixed it. All right, so see you in a bit. Hello, everyone. This is Professor Robert Solis. So here I am at home, and I was wondering what the heck is going on with the previous lecture, and why did my program fail here? Let me run the program so I can give you a demonstration of what the problem is. Everything works fine, basically, except all the way up to this part. Let me scroll down here. All the way where this deleting business going on, that's where the problem is. But anyway, let me just go ahead and let me see. Oh, did I stop the program? Yes, I did. I don't want to stop the program there anymore, so let me just go ahead and continue from here. So let me stop, run the program again. Okay, so how many ages are you going to enter? I'm going to enter 3. So let's just say 10, 20, and 30. We're going to add a value to the front of the list. We'll just add the number 1 to the front of the list, traversing the list. Yep, that's good. Get the frequency of a number. Okay, how many times does 20 show up? Just once. Okay, no big deal. All right, so traversing the list. Here we go. And basically it has reordered the list. Now, in this case, the program works. But in other cases, it does not work. Well, let me share with you what the problem is. And really the problem is down here when it comes to the items that I'm deleting. Notice that I deleted this guy. I no longer have this in the program. I've commented it out. If I were to uncomment that, then I'm going to get an error. But why? Okay, so let me stop right here and explain what's going on. So first of all, when I initially run the program, it looks like the head node is basically the parent's ages node is going to be the head node. So the head node is always going to be my first item, which is this guy right here. That's head. Parent ages node is also going to be that node as well. All right, now let's see here. It looks like me is going to be assigned whatever parent ages node is pointing to. That's what me is going to be. Okay, so what are you pointing to, parent ages node? I'm pointing to this guy. Okay, so me is going to be this node. And then whatever me's link is pointing to, that's what is going to be child ages node. Okay, so let me go over here. Oops, sorry. To child, to whatever me is pointing to, we're going to call that child ages node. And then, of course, the child ages node, that's going to be pointing to null. Okay, so I go through this process within the while statement, which is basically going to be reversing all the items. So let's just go through this. That way we can make sure that we are going through this step by step. It says, first of all, whatever the parent is pointing to, or in terms of the link, we're going to assign the null pointer to that. So let's hear parent ages node. Okay, that's this guy over here. I want you to point to the null pointer. Okay, so let me just copy and paste this and put this over here. So now, shorten this up a little bit. So graphically speaking, now parent ages node is pointing to the null mode, the pointer portion, that is. All right, so it takes care of that statement. Okay, so while child ages node is not the null pointer. Yep, child ages node is not the null pointer. It's this node right here. So what are we going to do? We want the link portion of me to point to the parent ages node. So we want the me portion to point to the parent ages node. So to make this a little bit easier to visualize, let me just do this. I'm going to move this over here. Let me move down a little bit further here. Take these guys, move them up a little bit. Should have moved them up earlier here. That's fine. All right, take this guy over here, move it up a little bit like this. And the link member of me is going to point to parent ages node, which is this guy over here. So me is going to point to parent ages node. So this is what happens. Okay. Then parent ages node is whatever me is. We're going to put that's what parent ages node is going to be. So whatever me is, that's what parent ages node is going to be. So we're going to call this guy parent ages node. And what are we doing now? Okay, child ages node, that's what's going to be assigned to me. Okay, so that's this guy over here. So me is also going to be whatever child ages node is. And then whatever I'm pointing to, whatever child ages node is pointing to, that's what child ages node is going to be. So what am I pointing to? It looks like I'm pointing to the null pointer. Well, that's what child ages node is going to be. So I'll just put this over here, underneath here. The null pointer and child ages node. Okay, very good. They're the same. Go back over here. As long as child ages node is not equal to the null pointer, well, child ages node is equal to the null pointer. So what do? We jump out of the while statement and we execute this next. And what does it say? Parent ages node. Let's assign that to the link portion of me. Okay, so where's the link portion of me? Okay, so this over here. And what are we supposed to point to? The me link is supposed to point to parent ages node, which is this guy over here. So let me just take this guy and do this, because that's what it says. The link portion of me, this guy right here, is supposed to point to parent ages node. This guy is parent ages node, so we are pointing to this. All right, so the next thing to do, oh, by the way, my son and his friend are practicing music, so sorry, I might get a little loud here in terms of the music. So I got to finish up this video quick before they get really loud. All right, so let's see here. We are going to say whatever me is, that's what head is going to be. So I go back over here. Me is this. So now head is going to be whatever me is. So I put this over here. Next, let's take head and let's assign this to next ages node. All right, so let's see here. Where's next ages node? This guy is over here. So what does it say over here? Head, whatever head is rather, that's what next ages node is going to be. Okay, so head is over here. Next ages node. We're going to put this guy right here. All right, so we're finished with this. Then we traverse the list, and so basically we're just simply going through all this until we display the contents of our linked list. Now watch what happens. The first thing we're going to do is we're going to delete head. All right, so when I delete head, I'm going to turn that into a red color. Okay, so that indicates that that's deleted. This node is in fact deleted. So if I try to delete me, I'm trying to delete a node that has already been deleted. And that's the problem down here with this code. So I don't need to delete me because this node has in fact already been deleted. I could still delete the parent ages node and the child ages node, but I don't want to delete this guy over here, me, because that's already been deleted. And so anyway, that was the problem with my code. Once I commented this out, everything is going to work fine. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.